So the PETG Trials and Tribulations, this one's PLA, pretty solid. And then I tried my first print with PETG and the whole thing fell apart. It's really chintzy. Look at this. This stuff just breaks right off. So I just did a few parameters and tried another print. This one is now much better, but still some issues over here. See, that'll that comes off a bit. This side is good. So I've got another print going with PETG and see if I can make this thing waterproof. And by the way, there's my drawing, and there's the code for it. So, you know, it took a bit of design, but it's, yeah, quite a few. How long is this thing? Anyway, that's what I've been doing the last week. Yeah, look at this. Anyway, looks pretty cool. And then this part is, right, it's this part. So I just printed that separately because this now mates to my water pump. Perfectly mates. Look at that. Anyway, fun times. There's the Nano. There's a, and then we have, and there you go, temperature and water level. There's the code running. It's getting a temperature of 15 point something rather close to 16. So let's pretty close. Not bad at all. 16.9 versus 17.2. Not bad. And what do we have behind the screen? We have a power supply. Look at that. Anyway, check out the specs on this thing. See that? 12 volts, 50 amps. So for 540 LEDs, that might be the puppy. See, check that out. That's the outputs. And otherwise, it's just the box. Can mount in another box, I suppose. But that's, yep, that's it. Yeah, not auto switchable between 220 and 110, but whatever. And then you can hide it. Or you can show it, hide it, show it, hide it, show it. So here's my cooling unit so far. So if you can see in here, there's a pump to take the water out, and there's the water inlet. And you can see the heatsink there that's going to sit in the water. And there, the red thing is a water level sensor, and the silver thing is the thermometer, which the heat pump then transfers to the heatsink on the bottom. And what happens there is I take this here part and I put it on, and that creates the channel that blows the air from the two fans through the cold sink, I guess you'd call it, not the heat sink. And anyway, fuck. Okay, I can't film and do this at the same time. Okay, so now we got the pumps wired up to, that's the fill pump, and that's the exit pump. So right now we can see we're reading, well, minus 20% for the water level, so it needs calibration, and 22 degrees. So let's put some water in. Needs more water. All right, I'm getting some water in there. Let's see what our readings say now. It's okay, now we can see water is at 120%, again needs a bit of calibration, and temperature is 20 point something degrees, and we can see we've got water in here. If you can see that, but it is leaking quite a bit. But now I can crank this up to 12 volts, and that has turned on the fan and the coolers. So the air coming out of this is now cooler than the air coming in here. If I can keep the water there to keep it from overheating. So what I need to do now is take the cold air coming out of here and loop it back in here so that it keeps going around. Anyway, so the cold air out of here will go back in here, it'll feed through again, and as you can see, it's got a leak. So I'm going to patch that up with my handy dandy silicone or some other glue. And the cooler with my see, that's what the Peltier looks like. This is the 12708, so this is the 8 amp version. So in this thing I've got one of these and then a 4 amp sitting on top of it. So that's 2 of these with thermal paste in between, and thermal paste to the heat sinks. However, it's not enough. So I'm redesigning this thing for 6 of the 04s. So that should be 24 amps. So we shall see. And this is the peristaltic pump, and it mates to a DC motor. So you can see how it's a 2.5 millimeter axle, and it goes in there, and that's what drives the pump. But I need to replace it with one of these steppers. This is the 28 BYJ-48 stepper motor. This is a flange I put on. That's just a 4 millimeter spindle on that, which of course doesn't fit in here. So I need to figure out how to get something from here that fits in there. Next project. So, waiting for some fans. Therefore, I put my cooling project on hold, and I'm on to my stepper motor linear actuator project, which is coming along. Check it out, man. Pretty cool. Being driven off this here Nano, and this is a 4988 stepper motor driver with which drives this motor. So if you see, if I press this button here is the move button. There she goes. Now going the other way, over here I've got a hall sensor. You can see it down there. It's got it glued down here. This button is the home button, so when I press that, this thing's gonna go until it finds the sensor, and then it should stop. Of course, if it doesn't, this whole thing's just gonna explode. It's gonna explode right in my face. Then better stop. Oh, come on, baby. You can stop. Ah, there it goes. Cool. Okay. And then we can move it again. Isn't that cool? So there's one driver there, but then I got this thing, which is the Uno, and has a shield on it, which can hold 4 of these. And I happen to have a few of them. So that's gonna go on to the Uno. So with this one thing, I can control 4 motors far out. And then I've been working on my pump. So I've got a couple of these coming in. The problem with it is I found these proper shafts. They're just a little bit too big, but it's going to work. But this one is a 4mm bore, and this needs a 5, so it doesn't fit. So I've got some arriving on Saturday. That's a 5mm bore. That's going to mate to this sucker. Then I'm just going to 3D print a little bracket that holds it all together using this shaft to drive the pump. I'll obviously chop this off so the axle will not protrude. So cool. I should have some neat shit going in the next couple of weeks. Hey, so making some progress. Okay, check this out. So there's the dip switch right now. It's only doing the first 3 bits. So that's reading a 5, right? 1, 0, 1. So when I press the button, we go to position 5. And then I can change it to whatever. Bring that one down, that's position 1. So I'll hit the button. There we are at position 1. And now we go to 3. Right, so I can make it go to any preset I want to go to, and eventually it'll be the Pi that provides the signal, not the dip switch. But that's how it's going to control that part of it. And then over here, I got the pump going with the little stepper, and built the bracket for it there, 3D printed those pieces. The problem with it is, I don't know if you can see that. Yeah, you see how that's pretty much as fast as it goes. So that will take a long time. Okay, so that's not going to work. So I'm going to change it to this one. So that one should do it. So I'll have to make this thing in here somewhere. Anyway, that's where it's at. Well, here is the cooling jig. So we've got the quad Peltier cooler here. So there's one Peltier there and one there, and I've got them sealed in for heat dissipation. So 2 here, 4 total. Water block here, then driven by a pump and into the radiator with 2 120 mil fans there. And this is wired in, as you can see, to 2 power supplies, because each of these draws 4 amps, so that's 8, plus driving the fans and the pump is going to result in 9.4, 8.8. Yeah, so drawing quite a bit, but it's definitely blowing cold air, so it's getting cooled through here. So the next step is to loop that cold air back to recirculate and get even colder. And there's the first piece of the, actually that's being printed. Yeah, it's almost done. So then that's going to loop the air back here, and then there'll be a duct that takes it across and loops back in here, and then this will be the cooling platform up on here. And then so the air will go out of this fan that's blowing this way, and this fan is also blowing that way. So there's two fans driving the air through, give it enough pressure to come across, come up into the cooling platform and through a duct back in here and recirculate and keep going over. So yeah, it's definitely getting cooler. So let's see, we've got 20.6, and yeah, this thing's down to 14 something, and it's it'll get a little bit cooler than that, and once I get the loop back going, I'm sure I can get this to below zero. So can't wait, but soon. Well, here's the latest setup. So it's got the enclosure, the air is all coming back through here, water cooling, fans running, pump running, power supplies going like crazy, Arduino monitoring the temperature, and look at that, minus 4 degrees C. Yeehaw! It's working. All right, we're about to energize the modern medicine with various chakras and magnetic fields. So here we go. I think it's done. 2 more coolers on the heatsink, and the glue is drying. And then I've got this thing with the clamps with the glue drying, and that's a 2-stage. And then I may even put a 3rd stage on it, because I saw a guy on YouTube who got the temperature down to minus 60. So that's just here for wait. That's just waiting for that to dry. It's going to take 12 hours for the glue to cure. It's this shit. That stuff. Anyway, so while I'm waiting for that to dry, I've got a setup here where I've programmed a sequence of sparks into it. So when I go here, okay, it does this. Cool, eh? 2-stage Peltier cooler. Let's see how fast it cools down. So we're starting at about 20.5. Stopwatch is at 0. Let's start the power supplies. Stopwatch is running. Let's see. Down to 8. It's pretty quick. Minus 6, minus 7, 8, 9, 10. So got the minus 10 in about 35 seconds. What's it at now? Minus 12, 13. Anyway, getting down there. It's probably going to hit minus 20. 16, and that took about a minute to get to minus 16. A couple of minutes later, let's see what it's at. Yeah, minus 22, not bad. And here it is a few minutes later with the ice crystals all growing on it. Pretty cool. So here's my latest cooler experiment ready to go. 6 Peltier unit, so it's got 2 here that I added to the previous one. And this is the one I had before with the 2 here and 2 here. So that was 4. Added 2 more to give it 6. And ready to try it out. So I've got this plate on here. That's a cooling plate. That's just the 11 gauge aluminum plate that I put on here with thermal glue. And that's connected to that. But I'm going to have to connect it to the water supply, which means I have to remove that without spilling anything. Anyway, should be interesting. Also interesting is need an additional power supply, because now we're pulling 24 amps and those guys over there will only put out 10 each, so I'm still missing 4 amps, so I'll have to get it from somewhere else. Well, here's the setup. Got the 3rd power supply added in. That goes in here, so right now I've got it routed to go through the ammeter to run a test just to make sure everything's okay. But the ammeter is in series, as you know, and it's got a resistance of about 1 ohm. But the problem is that the Peltiers each have a resistance of about 2 ohms. So the ammeter is going to reduce the current that you would normally have. Anyway, we should read a good reading. But first, we have to load water in. So we will need to do this one. Screwdriver at the ready. All right. So we've got power supply 1 is going to that, and for now I've got the cooler disconnected. So we need power supply 1 to be at 12 volts. That starts the pump going, and add some water. Oops. Okay, probably close enough for now. So the power supply is already plugged in. I just have a switch. So we should see theoretically 4 or 5 amps. Oh, we see 5.5 amps. Okay, that's perfect. So next step is I'll turn this off. I'll bypass the ammeter completely. We'll put the duct back on, and the pièce de résistance is we will put a shot glass with a 1/4 ounce of water in it to see how long we freeze it, even though we can't watch it because the thing's opaque. We'll time it and see if the water's frozen. But monitoring the temperature, Arduino's program is still running. That's the Nano connected to this probe to here and displaying there. Okay, so we'll set it all up and see how cold we get. Okay, setup's in place. Power supply 1. Power supply 1 is driving the fans, the pumps, and the cooler on this side. Power supply 2 is the cooler on this side, and power supply 3 is the cooler on the bottom. Okay, so let's see how long it takes for this thing to cool off. We will start with power supply 1. It gets the fans going. See, about 9 amps. Let me turn that on. Okay, 9. Can't get a reading here because no ammeter on this power supply. But what's happening to temperature? Let's see. Clear this. Dropping. Okay, it's now 1 minute, and the temperature is down to 8 degrees. Okay, temperature has now reached negative, and we've been running for almost 6 minutes, so it's not too bad to get a freezer going, but the water's really starting to heat up at 30. That would be the temperature of the water. That's the temperature of the, but it's getting colder. So we're at minus 2.75, and it's been 13.5 minutes. So we'll shut down and see if there's any evidence of ice. So here we go. First, it goes off, it goes off, it goes off. Wow, look at that. It is, in fact, frozen. Little bit of liquid still left, but, well, it's about half frozen. Okay, so not bad. 13 minutes. That's pretty good. I've been cheated, and I've got proof. Okay, look at this. TEC1 127.04, 127.15, 127.15. TE, thermoelectric. C is the size of this, so this is C size, which is 40 by 40 millimeters. 1 means single stage. 127 is the number of elements in this, so each of these contains 127 elements. And 15 is the maximum amperage. So if we look at the spec, the spec is right here. Input voltage 15.4 volts, maximum current 15 volts. So that's what the 15 is supposed to mean, right? Okay, so let's just see what these things will do. And by the way, I bought both these on Amazon. One of these, that would be this one here, cost $15.99. Actually cost $18.99. The 15s are sold out. The 12 is $15.99. The 15 was $18.99. Then I thought I got a deal. 10 pieces for $72. Half price. Well, let's measure this. All right, let's measure these. Power supply set to 12 volts, 11.99, whatever. Okay, over here we've got the leads to the 12704, which is the 4 amp version. Drawing 2.7, 3 amps. Yeah, so the 4 amps is, ideal conditions at 0 temperature differential and at 15 volts. This is 11. So that seems about right. Disconnect. Let's try the 127.15, which was $19. We connect that. And we're getting, wow, 10 amps, again at 12 volts. So seems pretty legit. That's a 15. Now we try the $7.15. And you can probably guess what's coming here. But this sucker is running at 3 amps. That is a 127.04. And I paid for a 127.15. So I've been ripped off, and it's no wonder my 2-stage wouldn't work, because I thought I was putting 15 amps through something when I was putting 4 amps, and the whole thing just got too hot and almost melted down. Okay, anyway, I've got some more things to try now. Another test, this time for a relatively full, so I don't know, more than 3/4 of an ounce each, and 4 of them. So yeah, it took about well, I kept it in there for 40 minutes. Don't know how long it took to freeze, but anyway, it's got the capacity. Playing with some misters. Now this one, you can see that down there. It's just a little ceramic disc in there that vibrates, and there's an oscillator inside that thing that goes at 1.7 megahertz, which is the resonant frequency of water, and only that frequency. Anything else, it doesn't work. So this effect only happens at this frequency. But when I plug it in, it starts so it puts out all this cool mist, atomizes the water. But the problem is that it splashes all over the place. That's why I've got all these paper towels. And if you try to suppress the splashing, it also suppresses the mist making. So it's kind of annoying, but it looks cool. And then this one is different technology. It's a metal disc that has perforations in it, and it goes at 113 kilohertz, which is another resonant frequency of water, and this only works at that frequency. So when I turn it on, and again, that's just a vibrating metal disc doing that. There's no air, there's nothing like that. So we got these two kind of things. This one makes this ground fog, and this one makes this steam-like thing. The other cool thing about this is it doesn't have to go in water. This thing here is just this thing here is just a bit of cotton wrapped up in tape. Then water's coming through here that's wicking the cotton up to the top, and I can put this thing on top of the cotton wick, and it starts doing its thing as well. So it makes it very convenient to install somewhere. This one you need some kind of water reservoir. So don't know which one I'm going to use. Probably both, I guess. But pretty cool. So here we have a liquid dispensing pump. This is a pump connected to a DC motor. It's a peristaltic pump, which means it pumps by squeezing this hose and going round and round and squeezing the hose and squeezing the water through, or whatever liquid it is. So that means that it never leaves this hose, which goes all the way through the pump. So it never goes into the pump mechanism. It never leaves the food safe hose. So that's pretty important in this. So I think I've got it timed out that when I press this button, it's going to dispense a 1/4 ounce. So when I press that button 4 times, we should get an ounce, and I've got it marked out on here. I'll zoom in on it. And there's the rest of my pumps. Got a whole bunch of them. Because I'll need 7. Okay, let's see how close that is. So I think you can see the lines on the shot glass. 1 ounce, 1 1/4 ounce, 1 1/2 ounce. All right, let's try this. Two. 3. 4. 'Ooh, just a bit under. Okay, I'm gonna have to recalibrate. And there's 1 1/4. 1 1/2. So it's very close. Just have to make a little tweak, and yeah, we'll have a way of dispensing things. Cool. So it's time to abandon a design concept, but I want to give it one last kind of video because it was a lot of work. So the original concept was to use one of these from Canadian Tire. It's just a little Tupperware thing to hold water, and then this would go on top, so that replaces this lid. So I cloned that design and then added a whole bunch of other stuff to it. So a heat sink goes through here. There's a water level sensor that goes in here, and a thermometer that goes in there. The concept being is that we would transfer the heat from the thing that we want to cool into the heat sink, which would go into the water here, and then we can pump the water out and we can pump more water in. So that's how this one would work. It would sit on top of that. And then the pump would pump it out through this hole. There's an O-ring that goes there, and the heat sink sits in here. So then we kind of put this on top with a couple of fans. So there's some fan brackets in there to hold that. And then we had this one, which was a duct that sits on the bottom. So the air goes through here. Cold air goes through here, and there's a heat sink that sits in here that cools the air. So that's the cold side of the heat pump. The hot side of the heat pump is sitting in the water. And it was also, yeah, there's that one. And there's that one. So that's the one that holds the cold side of it. And there's where the water would go. So that's where the O-ring mates, and the water goes there and gets pumped out through this hole. And that's where the hot water gets pumped out and more cold water gets pumped in. So what it looks like is this thing here, right? So all that is in place with the fans and the heat pumps, and you can see the water sensor and the thermometer. And that's the heat sink that puts the heat into the water. The water gets pumped in through here and then gets pumped out. You know, there's the pump is right there, and it gets pumped out, comes out the side. So, like I said, lots of work, and I'm going to throw it in the garbage because it doesn't have enough capacity. So the new concept now is here. which is the one I've been working on. So this one, instead of just having one Peltier cooler, has 6, and that blows through here and recirculates the cold air, so this becomes a freezer. And then the next concept is this one on top, which is the 2-stage cooler that gets down to about -25. And this one, the fans are going to blow down, so through the cold sink here, this is the cold side of the heat pump, the air will come out here, and that'll be the final -20-degree cooling to try to get it cold very fast. And this is kind of where the shot glasses and the cold water and ice will be made inside this freezer, and this is the final cooling. So that's the new concept. Unfortunately, all this other stuff is off to the trash can.